Today's topic is random variable. In last few classes, we discussed on random experiment, then sample space and events, and then probability, different definitions of probability, with different axioms, properties, and conditional probability, independency of two n, and then what is the conditional probability, and then Bayes theorem. The important, most important part is the Bayes theorem. So today we discuss on random variable. This is very important concept in probability theory is random variable. So what do we have? We have a, after a random experiment, we have a sample space, and we have a sigma algebra. Sometimes we take this sigma algebra a power set. So better I write this. Sometimes if sigma is finite, omega is finite or countable, if it is a countable, then what we take? We take this sigma algebra as a power set. If you take the sigma algebra as the whole power set, then it will be very easy. Very easy means it is more easier. But if I take other than power set, any other sigma algebra, then this is slightly complicated. Then all the events are then all the sets are subset are not event. If it is a power set, the sigma algebra is a power set, then all the subsets are event. Obviously, the events are subset. All the events are subset of sigma algebra, that omega, the sample space. This omega is called the sample space. We know this is called sample space. Set of all outcome of the random experiment, something like head, tail, or if it was twice, then head, tail, tail, and this is called event space. Event space. Now, if it's a finite or countable, we take this as a power set. That means every subset is an event. Obviously, all the events are subset, but all the subset may not be event. But if you take sigma algebra, the event space, as the whole power set, that means every subset is an event. So event and subset are synonymous in that case, but actually not. Now this is for sample space, event space, and we have probability. What is probability? Probability is nothing but a function from the sample event space. So it's take input as an event with some the axioms, with some condition. Not any function is event, so some condition. So this whole thing we have this, and this P is called probability space. This is also called probability space. So what we have up to this, we have a sample space omega, and we have a say power set, and we have function from here to here, 0, 1. Now this structure we have. So any subset is actually the whole subset. The whole subset. This is actually a single element here. So if A is a subset of omega, that means A belongs to that power set. It is a single element of this. Now this is a single element. This subset is A. Now this is somewhere here, which is probability, somewhere between from 0 to 1. This is the whole scenario of the probability space. Now we have another function. It's a very important function. So what we have up to this is a underlying set, sample space. Then there is a power set, or maybe that any sigma algebra, and there is a function on the real line up from 0 to 1, the lies between 0. Now we have another function from omega to real line, whole real line. This function is whole real line. not from 0 to 1. This is called random variable. The random variable basically a function from omega to r is also called real valued random variable, sometimes called real valued random variable, real valued random variable. So unless otherwise stated, we assume that it is a real valued random variable. If I say it is a random variable, that means it is a real valued random variable. But there are complex, maybe complex valued random variable, vector valued random variable, any other set maybe. But in that case, we say that it's a complex valued. But in our syllabus, in many of the situations, we consider only real valued random variable. So that's why we just drop the phrase real valued. We say it's random variable. Random variable means it is just real value. We can write in the bracket. But still, there is a other random variable other than real. If the two random variable, one is real valued and another is complex value, we have to mention which one is real valued and which one is not. We can't say this is random variable, that is also random variable. X and Y are both random variable. We have to say X is a real valued random variable, Y is complex valued random variable. That means the function from this omega to complex number, or maybe any other set. Now this is a random variable. Now what is the utility of this random variable? So actually it maps every element of omega, say small omega belongs to capital omega, is to a real number. This is just x of omega, which is a real number. So it's actually map a single element, single outcome. That is outcome. Omega is outcome. We know the sample space is a set of all outcomes to a real number. It may be negative. It may be greater than 1. So x omega is a real number. It may be greater than 1. It may be negative. Now, what is the utility of this? There's two utility. One is this just this actually the omega is actually abstract set. We actually, if we mapped one element to omega to x omega is another real number, that will be something concrete. Yeah. Because say take an example. Say if I say it's for an example. So you toss toss a coin twice. So the sample space is HH, HT, TH, and TT. Now what happened? Now if I define a random variable like that from from omega to real number, say we define x of HH is a 2, x of HT is a 1, x of TH is 1, and x of TT is 0. That means number of it. Actually, x the output of the x. The input is a outcome. Input is an outcome sample point, and the output is a real number, which is actually denote the number of heads. So instead of writing HH, we write 2, which is a better notation. Instead of writing HT or TH, we write 1. Instead of TT, we write 0. Something like the roll number or registration number of a student. The students is the actual outcome. The students, the set of all students, in some, say in a department or in the whole university. So this is a sample space, and we want to draw some random students from that whole sample space. Now we give actually registration number or real roll number. That will be easier to calculate, or easier to compute, or easier, the life makes simple. That's why we assign a registration number or roll number, something like that, rather than the name. So that means it is this is also a random variable. That roll number is a random variable. That not of the particular roll number. A roll number is a real number, but that the whole thing rolling, that this process is actually a function. The process is a function. What is the process? The process take a input as a student as input, and give a output the roll number of the student. So that is a function. Function is like machine. It's take an input here in the roll number. The process of roll numbering is actually is take the input as a student student as input and take output, that's roll number of the student. So that makes life simple. So something like random variable, that's also a random variable. If I assign some probability on the set of students, say student some students has say probability, choosing probability is say 0.01, another student is say 0.02, another is say 0.1, something like that. Then we say this also, this roll numbering also, the process roll numbering is also random variable. So random variable is something whose output is a real number. Is again it's a real value random variable. It may be complex value random variable. So it is a random variable means it is, unless otherwise stated, it is a real value random variable. So that makes actually life simple. So we should not define some real value random variable, something like that. X of h is say 0.2935. X of TST is e to the power sine 1. We should not define. This also random variable. Obviously, is also random. Any function is random variable, but it makes our life more complicated. So now this is a 2110. This makes life simple basically. It's 2 means it is h, 2 heads. So that's why sometimes called the random variable denotes the number of heads in 2 toss. So, but there is one problem. The problem is, can you recover this? If you know 2, it is HH. If you know 0, this is TT. If you know 1, the output is 1. Can I recover? Whether it is HT or TH, we can't recover. So that means it is not an injective function. It is a many to one function. So this is a many to one function. So is this a advantage or disadvantage? So if I say something is happening HH or HT or TH or TT, and if I say, oh, this is random is 2, takes value 1, takes value 0, that means if I say the output of the random variable, this have less information than the actual thing, the actual the input, that outcome. If I know the outcome, we know the whether it is HH or TH. Sorry, whether it is TH or HT. But if I know the output, if I know it is 1, we can't say what is it is TH or HT, because many terms. So that means the output for random variable actually lose some information. So if I'm using random variable, we are actually losing some information. There are 4 points actually, H, H, T, T, H, T, T, but we are replace that 4 points, 4 outcome in terms of 3 real number, 0, 1, 2. That means we are losing our information. We are losing on something like that. See, if I ask, if I say, what is the height of a student and what is the height of another student? If I have 3 students different, and if I ask what is the mean, if I ask only, if I know only the mean of the students, I can't recover the what are the 3 heights. But if I know the heights, we can easily get the mean. That means if I using random variable, the outputs are actually losing information. So random variable lose information. So the losing information is actually better or not. The question is losing information is desirable. So it may be so. You may say that no, losing information is not desirable. So, but actually, the actual thing is the opposite. Losing information is actually useful. Actually, we have to lose our information. We want to lose our information. Why? Why we want to lose our information? The one example is this. So there is a MCQs. So for another example is, so there is a MCQ exam with 10 questions. It may be 100 or it may be exam. 10 questions. Now some students got some number. Say it is true false. It's either 0 or 1. So if it is right, it is 1. If it is wrong, it is 0. So then I ask what is the number of the, what is the score? Say 7. That means 7 correct, 3 wrong. But this actually does not give the whole information. I can't recover that which 7s are wrong, which 7s are correct, and which 3 are wrong. That actually gives some information. some information. If I see that that student is actually the wrong, the maximum number of wrong answer is from this area, say area of this statistics, and maximum number of correct answer is from say mathematics. That means this student is strong in mathematics, weak in statistics. That we can say. But just taking the number 7 out of 10, we can't get this. So we are losing our information. This is random variable basically. This is random. So it's a correct, 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 wrong, correct, correct, wrong, wrong, correct, correct. This goes to 7. That means x of this equal to 7. X of this input, this is the outcome. This is the outcome. This is the outcome. Is 7. So another outcome is say all correct. Then it is a 10. All wrong. This is a. So how many numbers of the outcome is there? There are 2 to the power 10 many outcome, but we have only 11. 0 to 10. The output is 0 to 10. Number of outcomes is 2 to the power 10. So sample size, sample space, size of the sample space is 2 to the power 10. The cardinality of sample space is 2 to the power 10. 2 to the power 10 many options are there. C, all set up. But we just cardinality of this set, this range of this x is also called spec x. Spec x means the range of the x, range of the function x. This cardinality is very low, only 11. For it is n is 2 to the power n, and this is just n plus 1. Now we are losing information, but actually we want to lose our information. We never ask that in which question you are right or which question you are wrong. Everyone asks how many, what is your score? What is your score? How many get correct? You do correct and how many are wrong? Everyone asks that. No one actually wants that information. Which ones are correct and which are wrong? So this excess information, we no need of that. If it is needed, then we have to define our random variables differently. We can't define the random variables actually denote the number of correct answer. We can't say that. If we need that information. So random variable actually lose the information, but lose the unnecessary information. And losing unnecessary information is very important, because otherwise your information will be big, then your data will be very large. So it is a 2 GB, all information in the 2 GB. Actually, it's just 1 MB important data, but here actually a 2 GB data. But you actually 1 MB is enough. So then you have to compress all this data, compress all this information to a single information, or some 3 or 4 information. Like it is, so it is 1 MB data. So we have to lose there. Obviously, we should lose. We should lose a huge number of data. Just 2 GB from 2 GB to over 1 MB. This means just 2000. Just ratio 1 by 2000. We are losing so many. More than it's just 99.99%. Sorry, 99, no, 99.98%. 95. It's just 2000, 1 by 2000. So we are losing data, information, but we want that. So that means random variable basically lose some data and it creates some partition on this whole sample space. Basically, it creates some partition. So again, we look at the function. This is a real number. Oh, it's not 0, 1. It may be any real, maybe negative. Now, there is a function, is a random variable, is a function from here. Actually, it takes all these values from here to a single value. All this value in the single value, in another single value. Not the whole subset. Is every point on this set, on this part, is x of omega 1, say it is omega 1, omega 2, omega 2, 3, all these x of omega 1 equal to x of omega 2 equal to x of, this is some real number, say 3. So t is 1, h also 1, h is also 1, h is also 1, say number of tails, say this number of tails, this is the 4 gives the same value 1. So it's a creates a partition. Why it is a partition? Because obviously a outcome, that means a point on this this can't map to the 2 point. Since it's a function, a single input cannot give two output, but two different input give same output. So this random variable has a basically two advantage. One advantage is it may be abstract. The outcome may be are abstract, but after you are using random variable, the output of the random variable, which is a real number, so it is better. It is like simple to calculate all these things using some numbers rather than this whole name or whole sequence of HT or H or correct wrong. That is one advantage. It's a small advantage. A big advantage is the actual advantage is most important part is actually losing data. It is losing information, but losing information is necessary and is desirable because we have to lose our unnecessary information. So that means random variable creates some partition, and in every partition, this actually makes identify all these elements. Identify. You can't distinguish this element. Actually, you don't want to distinguish. If you want to distinguish, you have to define your random variable differently. So now again we go to this same scenario. So what is actually happening now? So we have this now. If I take a 1 point, say, if I take a point, say x on this real number, that means it may came from several values of this single x. That means there are several omegas are there. So that means this set, this is important, this part, which actually set of all omega belongs to omega such that x omega equal to x. This is a set. This is a set of, this is the actually subset of omega. Subset of omega is an element of the omega. Collect all the element of omega such that, sorry, it is x omega, not x. X omega equal. Now there is a question, if this the whole, if the sigma is not a power set, that is a problem, because we want to find actually sometimes this set is right as x equal to x. Sometimes write this. X equal to x means this. X equal to x means it is set of all omega such that x omega equal to small x. Something like probability of x equal to 3. That means probability of the subset, which is a set of all omega such that x omega equal to 3. It's a short notation, short version of this, the whole set. X equal to x. Sometimes also called x inverse x. Two notation are x inverse, is like inverse function, inverse image. Now we want to find the probability of this. So that means the probability of x equal to x is nothing but the probability of this set. Now there is a problem. If this set is, it is a subset of omega, no doubt. But if this set is not an even, then we can't find the probability. Can it be an even? It may not be even if the sigma there is not a power set. If sigma is a power set, then it is an even, obviously. But if sigma is not a power set, not the whole power set, then maybe for some x small x, real number, x is a real number, x is came from this real line. This set may not be even, and if it is not an even, not an element of the sample space, that even space, then we can't talk about the probability. That means we need the condition. We need this condition that, so for random variable, this is not only the real value random variable, it is not just a function, such that there is one more thing, such that this x inverse x, that set, this omega belongs to omega, such that all x omega equal to x. This set must be belongs to the sigma level. That means this must be the event. If I define a function such that for some x small x equal to 2, this set subset of that is not an event. This is subset of omega, but not an event. X omega belongs to omega for all omega belongs to omega such that x omega equal to 1. If this set is not an event, then we can't say this function is a random variable. So then this is not just another function, just not a function, is actually more than the function, is actually the inverse of some element to a special type of subset. So this is the whole scenario now. What is the whole scenario again? This is omega. This is the power set of omega, is actually the f fifth f. Sometimes we take the power set. and there is a function to 0 1. Sorry. Now we have a real line here, whole real line. Now we have a point and we can go back to this. Now if I take the subset of that, if you take any subset of that, if you take E as a subset of R, and what is the inverse of this E? What is this? We can take the same thing is a subset here, which is actually called X inverse. This is a function X inverse E. What is X inverse E? X inverse E is sometimes we call X belongs to E. These are all a notation. These are all a notation. Actual thing is that this is the right hand side is the actual thing. The set of all omega belongs to omega such that X omega belongs to E. X omega belongs to E. So if you want to talk on of the probability of this X some omega belongs to E, that means we are talking the probability. You are considering the probability of this set. This is a should be that should be a should be a even. If it's a power set, then no problem. Like make simple. Now, if we have a subset here, we come back to there to a set, and then that means is the element of here is the element of power set or in the sigma algebra. And now we can talk about the probability of this point. That is the probability of this, which is actually we write the probability of X belongs to E. This probability. Now this probability is a number from 0 to 1. That means we have a function like a 3-step. First take a subset of R, then go back to the sub. In the even space, there's an element of the subset of sample space, then which is the actual event, and so it's the element of the event space. So it's to take the probability function, and now we have a direct function from here to here. So this function is actually the composition of all these things. It's actually composed. So we actually is a function. Sometimes it's called p suffix x because it depends on the random variable x. It's actually the probability over this function. So px is nothing but a actually is a again is a probability, but is take input as a subset of real number. Now take the input as a subset of real number and give output from 0 to 1 to the 0 to 1. Output actually the probability of that x must be there for different random variable, different subset will be there. So probability of x, which is nothing but this probability of x belongs to A, which is the element of 0 1. So remember, these two probability are different. These two probability are different. One probability is just a probability on the sample space, on the event space, and this probability is actually from the real number. So this function is called px. Sometimes call it is probability induced by x. Probability induced by x. This x. See, sometimes it's called distribution. This is also called distribution. This probability is called probability distribution or distribution of x. Sorry, it is not an induced by x. Distribution of x induced by p. Induced by p. So distribution of x induced by p. So actually two things is involved there. So one is the underlying probability space, the probability of head, or if the probability of head is changed, then this probability will be changed. One thing is there, and another thing is the random variable. If I say random x of h is 1 and x of t is 0, this is one thing. If I say x of h is y of x is say 5 and y of t is say -3, then the distribution will be different. So distribution actually involve two things: is take one input and give output. The input actually involving that random variables, and the output is actually after impose the condition after applying the probability at given probability space. So one example is there to be easier. So take this our well-known example of coin tossing. Toss a coin twice or maybe thrice. Say it will be eight different outcomes, HTT, THH. We know there are 2 to the power n many different outcome. Then TTH and then TTT. And we just consider this whole power set as a our signal algebra. So any function is actually random variable. In that case, any function from x to this is random variable. From from omega to r is a real random variable. Now we define something like that: x omega is number of h occurs in omega. Omega is h or maybe. That means what is h x of h is just 3. And x of say TTTH is just 1 and x of TTT is 0. So this is random variable. Now if I ask what is the probability of x is equal to 2, that means what? That means probability of is actually probability induced by 2 is a p of x of that set, this set. The probability of set 2, which is actually p x equal to 2. If it is y, then induced by the distribution of y, then it will be different random variable. Now, how do you know what is a different thing? Here now it will be different. So this is omega, so that x omega is equal to 2. But what are the x omegas equal to 2? There are 3 different elements are there: HHT, HTH, and THH. 3 different element has x omega equal to 3. Now this, what is the probability of this? If you, all this is if the coin is a fair coin, then it is a 1 3 by 8. If it is not a fair coin, if it is a say coin with probability of head is say p, head is p, where p is from 0 to 1, and if I take q equal to 1 minus p, the probability of tail, then it is just h is, and the toss are independent. Tosses are independent. Since in the independent is a product of all these 3, so h, probability of h into probability of t, that is which is p into q, so it is p square into 1 minus p q, and second also it is p square q, third also it is 3 many, the 3 p square q. So what is the probability of x equal to 0? It is just q square q cube. What is probability of x equal to 1? One head, only one head. There are 3 different choices of that, so it is called 3c1, p to the power 1 and q to the power 2. There are 2 tails. And if it is a 2, then it is 3c2, which is actually 3c2 is again 3c1, which is 3. P square, 2 head, so p into p, then tail q. And what is the probability of x equal to 3? Only one case, so it is pq. So this is actually a distribution of the probability of with this x induced by that probability, that small p thing. Small p change is in this probability will be changed, and this is called distribution of this random variable, and distribution also known as, is this sum is 1? Is yes, it is sum is 1 because it is just came from p plus q whole to the power 3. P plus q whole to the power 3 is just, we know p plus q is 1, so it is just 1, and in this side is all these probabilities. This first term, then 3p2 p square q. So if we want to generalize this thing, if we take 1 as a 1 to the power n is any natural number, so maybe 100 or maybe 1 core. Actually 1 is p plus q to the power n, and we know what is this thing. This is called binomial theorem. NC0 plus NC0 q to the power n, or NCn better you say. It will be better the other way. It's okay. NCn. NCn is NC0 is same. So p to the power n. So n many success, n many head. NC n minus 1. So n minus 1 many head, and one tail, only one tail. The tail probability of tail is q, 1 minus p. So NC n minus 2 p to the power n minus 2 p square. We know this thing. We know this is called binomial theorem. And this, since it is binomial theorem, all the properties, some of the property must be 1. Oh yes, it is 1. Since the binomial, using binomial theorem, we are proving this is 1. This distribution, this random variable is also called binomial random variable with the parameter n and p. You can change your n, you can change your p. If the underlying probability of the head is changing, that means the probability space is changing. So p, small p is changing, and if you change your toss, number of toss, then this number of toss is n. So you can change that n. You have two choice. You can choose your n number of toss, and you can choose your p, the probability of head. It may be it for several cases it may be half. If it's is a fair coin or the unbiased coin, is called half. If it's a biased coin, it is not a half. The unfair coin. So maybe probability of head may be larger than the probability of tail. It's an unfair coin, or an unbalanced coin, something called unbalanced coin. A balanced coin means it is the fifth, half of probability of head is half. In that case, it is. So you are changing your n and p as you. In problem, you have to find what is your n and what is your p, small p. But your random variable is, remember, your random variable is the number of head occurs. Then this will be the probability, and in that case, that your probability of r, in general case, probability of x equal to r must be number of r head is r, that is ncr, p to the power r, 1 minus p to the power n minus r, meaning 10. So if you want to find, no, we want, this is like something like the score, total number of head. We don't know when say n equal to 10 and say x equal to, we want to find x equal to 3. That means number of head is 3. We know number of head is 3. What is the probability of that? But we don't want to know, we are not interested on this, where this 3 head occurs, whether it is HHH, TTTTT, or it is TTTTT, then HHH. We don't want to know this. We want to know the whole total probability. All this, there are NCR many, 10C3 many choice. We capture all this thing as a together. So 10C3, P to the power 3, Q to the power 7. But if it so happen that in our problem we want to find the not only the number of it, we are not interested in the number of it actually. We are interested in the fast success, fast H occur. Where the fast H occur? Whether it is occur in the first time, whether or it is occur in the 10th time, at the 10th. That may be an interesting case. After how many failure the success is occur? That is also important random variable. In that case, what happened? In that case, what will be the sample space? First important is, what is the sample space? Now, say if I were tossing 10 or say 3, so it may be so happened is head occur first. So stop. Head occur, stop. Don't be tossing. So success occur at the head means success, say, okay, in the first time. If it is success occur, the experiment is stop. If it is a failure, then success. Failure, success. Oh, it is stop. So, oh, one more thing, sorry. Tell. The toss thrice, maximum thrice. Once head occurs, stop. This is the sample space. Now this sample space is not 8 element, only 4 element. So what is the probability of this? Probability of head is that containing head, which is actually P. Probability of then next one, PH, is Q into P. What is the probability of then TTH? It is Q square into P. And what is probability of TTT? T is QQ. And you add this, you can easily show that, see that this is 1. It's just the GP series geometric progression. If we add this geometric progression term, we'll get is just 1. And it may so happen that it is infinite many times it is occur. Say, unless you are head occur, you have to go tossing and tossing. So then it is infinite. Now it is infinite. Now the sample space is infinite. All possibilities is infinite. It may be 1 chord tail, then head. It may be 10 chord tail, then head. So in that case, what is the probability? By the way, we define here random variable like that. X equal to h, we say only 1. First time it's occur. H equal to th, it is 2. Second time occur. H equal to tth is 3. And if x equal to ttt is 1, there is no head, so it is 0. But here it is not 0, it is only here the spectrum of this spec of x, that is the output of this range of this function is just 0, 1, 2, 3. But here, what is the spec? Spec of x is, we define x like that, and the number of times it's to first head occur. So x of h is 1, then x of say t, how many t's? r t's, and then h will be r plus 1. So spec of x then 1, 2, no 0 there, no, whole natural number. And obviously your probability of this x equal to r, that means first r minus 1 many is till r minus 1 then head. It is not NCR, it is only one possibility, all till then last head. If we add this thing, what will get? We should get 1. You have to check whether we are getting 1 or not. So we are, so first it is p, then qp, then 2 tail, then head, q square p, dot dot dot, say infinite series. We know the infinite gp. If you take p common, we have an infinite gp with a term which is less than, the positive term which is less than 1. Infinite gp is some convergent. It is the sum of the infinite gp is exist. We know if it is from 0 to 1, actually minus 1 to 1, but q is less than 1 and greater than 0, so it is between minus 1 to 1. That means the sum is convergent, and we know this is just 1 by 1 minus q, which is p. So p by p, which is 1. So sum must, all the sum of the all probability must be 1. We are checking it's 1. It's a geometric progression. It is a geometric progression coming from all the term is coming from the geometric progression of this infinite geometric progression. So it is called geometric distribution. This x is called geometric. Since from the geometric progression, it is called geometric distribution. And this random variable is called geometric random variable, geo. This x follows geo. So what it is called p, or 1 by p is called p, I think so. Right? It's called. So these are two distributions. Is important. One is geometric, one is binomial. Next class we see some more other distribution, and to find how to find this expectation on variance or all this thing of this distribution, different properties of this distribution. So for today it is up to this.